Okay, so now we will start the final chapter in this course, and it's a short chapter, so don't worry about it. It will finish in just 1 hour, but we will do a practice on it to understand it better next time. So just let me open it. Okay. So in this chapter, we will learn how to do an economical evaluation of an energy project. Okay. So as we said, we are saying renewable energy is very good. Renewable energy will protect the environment. Renewable energy will reduce greenhouse gas emissions. All of this is very good. But you know that for any project to be installed, uh, people mainly look at the economical side more than the environmental side. And here sometimes we have the role of the country, of the government. So if you have in developed countries, we force people to adopt renewable energy, even if sometimes on the cost level, especially in the first years of when we start to use the renewable energy, the efficiency was not very high as now. And but in developed countries, the government forced people to use these type of energies by imposing taxes, by saying that you should use them, you should not use, for example, fuel energy, etc., because it's harmful to the environment. So sometimes the government in such cases play a very important role to enforce people to use renewable energy. Now, what we try to do also is to ensure also at the economical level good benefits, and this was possible through advancement in research and increase of efficiency. Now, in this chapter, we will learn how we do the evaluation of a project. So to evaluate a project, we should look at several aspects. We should look at the environmental aspect, at the economical performance. So we have several tools to assess the performance of a project on the environmental level and on the economical level. So for example, on the environmental level, we have what is called life cycle assessment, which consists on calculation of impact indicators from energy and material flux inventory during the life cycle. Okay. For example, in this case, we can see what is the impact of all materials used in this project on the life cycle. Another issue is the carbon accounting method, which consider what is the amount of direct and indirect greenhouse gas emissions related to the project. Another factor is the ecological footprint, which compares the human resource consumption and waste generation to planet Earth's ecological capacity to regenerate resource and to absorb waste. So it will not look just at the current case, but what will be the effect on future generations. And it's expressed in unit area for a given population. This is for the environmental performance. In this chapter, we will not go into details in the environmental performance. We will look at the economical performance. We have several factors. First, we have the life cycle cost method, which consists on a cost evaluation during the life cycle. Second, we assess the net present value, which represents the profitability of the project. Okay, so we take a certain for each year we can calculate what will be the gain until here. Yani, of course, for the first years you will have a negative value for the NPV because you need time to compensate the initial investment and the maintenance cost. But after a certain year, which is called payback period, then you will start to gain from your project. And another factor is the CER method, capital enrichment rate, which is a method developed to do the analysis of the profitability of renewable energy projects. So we will go over all of these factors of economical performance. So, but we should pay attention a lot because all of these methods are based on several parameters. And sometimes it can be difficult to check the validity of each parameter. What do we mean by this? So for example, let's say from 2 years, let's say if you want to invest in Lebanon, you have a risk factor. but this risk factor is much lower than the risk factor today. And it just from maybe not 2 years, less than 2 years, the risk factor was acceptable. Now no one will invest in Lebanon. Yani sometimes parameters are not very clear, and we cannot always have a good prediction. Okay, and these parameters will affect a lot the estimation, because when you want to study when you want to do an economical analysis, you have a very long period of time, and over this period of time, many factors can affect your project. So this is why, in general, we should consider a certain confidence factors that we will talk about. So more risky is the country where you are investing. You should put into consideration that you should gain a lot to compensate for many losses that are possible in the country. Okay. So this is why sometimes we have to do assumptions. We have to take risks. Okay. But in any analysis we do, we should say what are the factors that we considered. What are our assumptions? So if we consider a risk, we should give a number. We based our analysis on a risk equal to this percent. Okay. And several times we do several simplified assumptions. So for example, let's say you have with time you have increase in costs, let's say, for example, or with time money will lose its some of its value. So we should do is this prediction. You can consider that it's varying at a constant rate, but in the real case it might not. So you have to do some simplifying assumptions to do a preliminary calculation to assess the profitability of your project. And the results you obtain, of course, will depend on these assumptions. This is why when you expose the results of your economical analysis, you should state what were the assumptions you based on to get these results. Okay? And in general, absolute results are not relevant. So always we should we should give relative results. What do we mean by this? So I can tell you this project after 10 years will give you a gain of $1 million. Okay, يمكن for one person $1 million is very good, but if you have a very large company and the initial cost is $100 million, then if you gain $1 million after 10 years, it's nothing. So you should always compare. You should take a ratio of the gain over the investment, for example. Okay. Now, in order to do the economical assessment, you should answer several questions. So first, how much will it cost and how much will it pay? So I should know what I should put as investment. I should know what are the costs of maintenance, what are the continuous costs that I should put to ensure the continuous function of my system. And on the other hand, I should know how much I will gain money from it. Okay. And then I can compare several solutions and several projects to decide on the best option on the economical level, and of course on environmental and other levels. Now, one of the most important factors when you are when you are studying the economical assessment for a project is how to take time into account. Okay, so for time, you have several parameters that will describe time. You have the interest rate, the inflation rate, and the discount rate. Okay, so for example, we will see in detail each parameter. So mainly we talk about interest rate when you want to take a loan from the bank, because the bank will take a certain percentage from you. So the interest rate is mainly involved in loan analysis. Now, the inflation rate is also very important because, as we said, the value of the money can change with time. Yani if you buy, let's say now, if you have $1,000 now, it will buy for you more than it will buy after 10 years, because the value of the money can be reduced with time. Okay, and this rate is evaluated by statistic institutes, and it will depend on the state of the country, of course. So if you talk about the dollar, it's not like you talk about Lebanese lira, of course. Okay, so the risk factors, the inflation rate will be very different. Now, the third factor is the discount rate. And what is the idea of the discount rate? Is that the value, it's related also to the if you want the value of the money. So what can I buy with this amount? Okay. So if we talk, for example, if we say that in this year let's say at for year end, okay, I can buy with $1,000. I will buy this object. Okay, after 1 year, I cannot buy it with $1,000. I need more. Okay, so this is called the confidence in the future. So how much my country is stable, how much my situation is good. If my situation is good and my country is stable and everything is okay, I will consider that A will be close to zero. So the value of my money will buy for me the same thing. So I am fine. Okay. So in this case, A can calculate, if you want, the ratio of the value of an object at year n plus 1 over its value at year n. So 1 plus a is vn plus 1 over vn. Okay, so and you can see that a is always higher than 1. Okay, so with time, any object will have a higher cost because this is if you have a stable case, a will be 0. But in general, if we have always some risks, this is why, especially in countries where we have a lot of changes in political and economical issues, we always have high A. And we say that when we have high A, we have low confidence in future. So the value of objects will increase. And if I want to buy an object, it will be more difficult to buy it with time. This is the idea for this country. And mathematically, I can write it in this equation that the value at year n plus 1 is equal to the value of year n times the value at times the value at Vn times 1 plus n. Okay, so the ratio Vn plus 1 over Vn is equal to 1 plus n. This means that if I have confidence in future, A will be close to 0, and the cost of a certain object will nearly remain the same with time. However, if I have low confidence in future, then with time, the cost of a certain object will increase. Now, when we do the life cycle cost, we should first assess the sum of the present costs during the system lifetime. Okay, and to assess this term, it is equal to the summation over years. So from year 0 to year n of the cost. But why we do over 1 plus a to the power n? Because if, as we said, if something will cost, let's say, in this year it's costing ci, okay, the equivalent value uh, at year 0 is ci over 1 plus a to the power r. Now I'll give a numerical example. Okay, let's say let's say when you calculate the life cycle cost, you should calculate it with respect to one reference. Okay, so let's say we invested a certain amount of money for year 0. Okay, and with time we need maintenance cost, we need some cost for operation, etc. So when we add to the initial investment maintenance cost and any other operation cost, then we should take into account what were their equivalent value at year 0. Okay, their equivalent value at year 0 is we don't have the same value, because if something is costing now C0, it will cost after C0 over 1 plus a to the power n, which is the number of years. So if I have $10 now, let's say I can buy one package of a certain object. After 10 years, I might be able to buy 2 packages. Okay, so this is why we say that the cost after a certain year will be reduced, because as we said, the value of the money is reduced with time. So I can say that I divide the cost, which is now, I divided by 1 plus a to the power I, where I represent the number of years. Okay, so for the first year, let's say, for the first year, I is 0. So I just consider the initial investment. Okay, so here, if I take year 0, what do I get? I get the following. I get C0, the cost at year 0, over 1. And what is the cost at year 0? This means the initial investment I put. So the first term in your equation is the initial investment I. Now, you will add Let's say they are telling you we expect that we need each year $100 as maintenance, for example. Okay? But the $100 now is more important than the $100 after 2 years. This is why for the first year, I will do 100 over 1. Let's say A, for example, if I give you an example, A is 10%. Let's say the confidence in future is 10%. So for the first year, I will divide 100 by 1 plus 0.1. Okay? But for the second year, as we said, the value of money is decreasing with time. So I have plus 100 over again I will do divided by 1 plus 0.1, and it's already over 1 plus 0.1, so I get over 1 plus 0.1 square. And more I add years, I should add the coefficient. This is why we say it's ci over 1 plus a to the power I. Okay, now if you want to do the calculation over 30 years, of course you will not add 30 terms, and you have a mathematical formula that, if you remember in school, you have taken the geometrical series. If I have a geometrical series, I am summing terms, and always I am multiplying by the same factor, which is 1 over 1 plus a. Okay, so you can mathematically calculate this term. The only condition is to assume a constant. As we said previously, we have many assumptions to simplify calculation. So to simplify calculation, we set a constant, which is the confidence in future. And of course, it might be variable, okay? But as we said, we should do some assumption to simplify the analysis. So we will take a certain constant value of a. So for constant value of a, from math, I can replace this formula, which is corresponding to a geometrical series. I can replace it by 1 plus a to the power n minus 1 over a times 1 plus a to the power n. Okay, so in this way, I can calculate the whole cost during the n years. And I should add for it, of course. So I do the calculation from year 1 to year n, and I add to it the investment, the initial investment cost. Okay, therefore I can assess at any year, and for year 10, what will be the total cost I am having. Okay, and they say some of the present costs, because their value is measured relative to now. This is why we divide by 1 plus ai, because I want to measure their value relative to the current time where I start. Okay, so now once we get the total cost, okay, now we want to assess if our project is profitable or not. So what should we do? We should compare the income to the inputs. Okay, this is called the net present value. It corresponds to the summation of present cash flows. Okay, which is comparison of income and costs over the observation time.
Doctor,
Yeah,
what slide are you at?
7.
It's not showing.
Yeah, I will. Let me see what's the problem. It is the case long time ago or just now?
No, I think you were explaining something on slide 6.
Okay.
Were you writing something in slide 6?
No, no, I didn't write anything.
Okay.
I was just annotating here. You are seeing my screen now?
Yes.
Okay. I was just annotating the formula here. And
Okay, thank you.
okay. So now I will move to slide 7. So slide
Yes,
7
now it's showing.
okay. It represents the net present value, okay, and to assess the profitability of the project. So it will do summation of incomes minus costs. Okay, maybe the formula is not very clear here, so I'll write it myself here. So you do summation. It's the summation, okay, of incomes, which is called RI, minus, so it's summation, and the summation is from year 0 okay, to year end of RI, the incomes, minus CI, the costs, over over 1 plus A, the power I. Okay, so in this way I can compute what is the net profit for each year end. What will be my net profit, not net present value? If the net present value is negative, this means that I didn't compensate yet the income I put in my project. When it becomes zero, and now from now on I will start to gain from my project. Okay, so RI represents the income per year, and we are reasoning here at constant currency. What we mean by this, we assume we don't have fluctuations in the money value. مش money value. انتبهوا, there is difference between the money value and the currency, constant currency. For example, for 30 years in Lebanon, the lira was stable. So you have 1,000 $1 equivalent to 1,500 lira. So you have constant currency, but this will not mean that you have a good confidence in future, because the value of the money is changing. And what you can buy from 10 years with a certain sum of money is different than the value now. Even if you have stable currency, you can have, due to inflation, we say, if you want, due to increase in costs of life. So the same object will cost more with time. This is related to A, which is called confidence in future. Okay, so A is the discount rate, and N is the observation time in years. And the difference between RI and CI is called the cash flow. And the project will only be profitable starting when NPV becomes higher than zero. And we will see together that even if NPV is higher than zero, we cannot say, okay, it's profitable directly, because there is a lot of factors that we didn't account for. This is why we will see after that, to be on the safe side, we say that the project is economically viable when the NPV constitute more than 30% of the initial investment. To take into account the risk factors, to take into account many issues that I am not aware of. Okay, and this we will see it in the capital enrichment rate after. Now, let us take a very small example to see what is the importance of the net present value. Okay, so here let's say we studied a project, and as we said, when we study the project, we do some assumptions. So we should assume this is the discount rate. Sometimes what we do, we try several rates to see what will be the difference if we change the discount rate. So let's say we are in a country that is stable, where in general we don't have a lot of inflation, the cost of objects is not varying a lot. So we consider that the rate is close to zero, and we do the analysis. As you can see, you have the black curve showing the net present value with time. And it's clear that, of course, first the net present value is increasing with time, because you are gaining with time, you are gaining money from your project, which will with time increase the net present value. But for the project that you are studying, if you look at your values, they are always negative. So even if I have a discount rate of 0%, it's not working, because I need, when I reach 20 years, I am already with a negative NPV. And even the maximum of NPV is at 15 years, and after this, it becomes to drop. Why it is dropping? Who can tell me? Who can give me a reason? Why the net present value can drop, for example? Due to what?
For example, operation costs that are becoming higher with the
Very
materials
good,
that they create.
very good. With time, your equipment will not be as efficient as it was at the beginning. So sometimes, after a long period of operation, the maintenance cost and the operational cost becomes dominant over the gains. This is why the net present value becomes to decrease. So here, at any time, NPV is negative. So we can, and even for a discount rate of 0. So even if you have complete confidence in future, you have negative results. So no need to continue the analysis here. No need to take A higher than 0%, because of course, if you have A larger than 0%, NPV will be lower, because lower is the confidence in future, lower will be the NPV. And as A increase, this means that your confidence in future is lower, and this means that NPV will be lower. So since for 0%, which is the ideal case where I have complete confidence, my project is not profitable, I can stop here my analysis. Or what I can do is try to do a small analysis to see why my project is not profitable. I can have several reasons. First, the investment might be too high, so I can try to reduce my investment if possible. Second, I can study the selling price. So let's say I am designing a solar system, for example, to sell electricity. So I say I should sell at a higher cost in order to benefit. So one possibility is to increase the selling price. A second possibility also is to try to minimize maintenance costs, of course, if possible. Okay, and another reason that can lead to negative net present value is low productivity. So, for example, if I'm just producing for a small village, the incomes might not be very high. So I should cover a larger area to have more productivity. If I try to do all of these and my net present value remain negative, this means that my project is not economically viable and I don't start with it. Okay. Now, concerning the selling price, I want to tell you something that, for example, in developed countries, when we started to use solar energy, the cost of electricity compared to fuel electricity was much higher. But because government forced people to use this source, يعني this track of systems was started. And sometimes, as we said, we need a very powerful government to help in implementation of such strategies, which is not our case, of course. So, if we continue, we have in this other example, we are studying another project, okay? And now we are comparing several discount rates. So as you can see, of course, the black curve is the highest net present value, and it's expected that it will have the highest confidence in future. It's corresponding to 0%. So, and 0% in general is very optimistic. Yani I consider that my country is very stable, nothing is changing with time. So this assumption is not a very good assumption when I want to assess the profitability of my project. So now here I can vary my discount rate to see what will be the effect of risks on the net present value. So here I can see, for example, that between 0 and 3.2%, which correspond to the purple curve here, in this case, I have a positive net present value. On the other hand, if I increase more the A, so if I have a lower confidence in future, then it's not profitable because I get a negative value. This is why we define an important parameter called the return on investment, ROI. It means what? ROI, so this is here, the ROI is equal to 3.2. What is the meaning of return on investment? It's the confidence rate that will give me a net present value of 0 at the end of lifetime. So here, if you look at your graph, at the lifetime is 20 years, okay? The confidence rate, the discount rate that gave me a 0 value at the end of lifetime is 3.2. This means that this is called return on investment. So it is the discount rate just needed to have a balance at the end of lifetime. And of course, it's not, yani, this discount rate is not good. Yani, it's not good to be just have a balance. So if I tell you, I will give you a system that will not give you any profit after 20 years, of course you will not go for it. Okay, especially if you don't have constraints that force you to go for it. So what we do in general, we should ensure if higher is ROI, better is. Okay, so in general, we try to increase the ROI, because when we increase the ROI, this means that even if my confidence in future is small, I still can get a profitable project. So here from this curve, you can only say that between 0 and 3.2, my project is fine if you want, and not even fine, because a net present value of 0 at the end of lifetime is not acceptable also. We will see a criteria that will assess what is the acceptable net present value. And here, between 3.2 and 10%, so of course it's not, you get a negative net present value, so it's not good.